ওকে চল আমরা স্টার্ট করছি ভিডিও নাম্বার 4. So ultimately I can say that कि for any medium in between the charges, চার্জগুলোর মধ্যে যদি কোনো একটা মিডিয়াম থাকে আর যার পারমিটিভিটি হচ্ছে এপসাইলন, permittivity of that medium. ঠিক আছে? So don't go to find out the reason behind this, why this is given the name permittivity. Actually it came from the concept that is like permission, right? Ki two charges will attract each other or repel each other. It deserves a permission from the medium, right? If the medium doesn't permit, তাহলে কিন্তু ফোর্স অ্যাপ্লাই করতে পারবে না. হোপফুলি আমি ক্লিয়ার করতে পারলাম, রাইট? নাও for free space, epsilon is equal to epsilon naught, right? If you put air inside, then epsilon should be written as epsilon naught. Okay? So then what people did, you know, they found out another constant, K. This is another constant, K, and it is given the name dielectric constant. But what is dielectric constant? But a dielectric constant is the ratio of permittivity of that medium to the permittivity of free space. Okay? People brought this. Can? Well, in that case, you can write epsilon equal to K epsilon naught, and the formula becomes easier to remember. The formula becomes easier to remember. Why? Well, look, for free space, epsilon to epsilon naught. Therefore, K will come from here, epsilon naught by epsilon naught, that is 1. For free space, K becomes 1. Right? So anybody and everybody can remember that F is equal to 1 by 4 pi epsilon 0 q into small q by r square. In addition to that, you have to put a K beside. And if there is no medium, that is free space, then put K is equal to 1. But if that medium have something, that space have something, suppose I put water inside, দুটো চার্জের মধ্যে আমি ওয়াটার দিয়ে দিলাম, so I just have to know the dielectric constant of water, right? So এটাকে আনার কারণ আর কিছু নয়. The reason behind bringing the concept of K is nothing but to make remembrance easier. এটাকে ইজি করে মনে রাখতে পারি, because K is a dimensionless, unitless quantity. It is a unitless and dimensionless quantity. It is a pure value, right? Why? Because if you look, this and this, they're same thing, na? Their origin is same. So the ratio of same thing always becomes unitless and dimensionless. Is that clear? এখানেও তাই হচ্ছে. Let me give an example. If somebody says me कि two charges 1 coulomb each are placed at a distance 1 meter apart in a medium, inside a medium having dielectric constant K is equal to 2. Okay, what is the force between them? So if somebody asks me this question, then it becomes very easy to me. Why? Because now I just have to remember it like this: 1 by 4 pi epsilon naught q by r square, and in addition to that I have to put a k over here. So I know that 1 by 4 pi epsilon naught, this is 9 into 10 to the power 9, right? I have that idea. So the formula becomes this. What I have to do now? I just have to put the things. K is given to, this guy is a 1, or a 1. So it becomes 4.5 into 10 to the power 9 Newton. So it becomes easier to remember. That's why the concept of dielectric constant is brought. And again I am telling you, don't try to go behind the reason why it is given the name dielectric constant. Because they like this type of things. One, a narrow explanation is that it is electrical thing, electrostatics. So there are two electric fields are involved, one for free space and the other for that medium. So roughly you can say that is the reason behind giving the name dielectric, and it is a constant. Okay? But that is not the proper explanation. People, the scientist who has not given his name, he thought that let us give this type of name, and that's why that's called dielectric constant. So like its name, my name is John, you have a name, right? So especially nothing but our parents preferred to give us these names. Okay? So you have to remember the names only. Okay? So I shared my second knowledge where I introduced the concept of dielectric constant and how to remember Coulomb's law. Hopefully this is clarified to everyone.